Hello everyone, welcome to my channel. Myself Vikas Nitsar. So in today's lecture we're going to see how to design a FIR filter using a window function. So in a last video we learned about the how to design a infinite impulse response by using different techniques. So in the same way you can design a FIR filter. So basically what is the difference between a FIR filter and IIR filter? That is the important case. So basically we already know that the most important difference between FIR and IIR is nothing but FIR filters are always stable as compared to the IIR filter. The reason is very simple, because in FIR filter all the poles are always present inside the unit circle, and in IIR filter the poles may be present outside the circle or may be present inside the circle. So that's why in IIR filter maybe sometimes is stable or sometimes is a marginally stable or is unstable, but the FIR filter is always stable because their all poles are present inside the unit circle. So in the same way, by using same concept, we can design a FIR filter, that is nothing but finite impulse response filter, designing using a window function. So basically we know that there are different window functions are available. So the first one is a rectangular window, second one is a Hamming window, then Henning window, then Blackman window, then Kaiser window. So there are different windows are available for the designing of a FIR filter. But in our programming, so we're going to design a FIR filter on a MATLAB software. So for that we can use, or I'm using actually Hamming window, Henning window, rectangular window and the Blackman window. So herewith we can start the actual programming. So for the programming purpose you have to start with your new, just click on the new file, then you can click on the script file. When we click on the script file, then one window will be open, that is nothing but editor window. This window, for this window just you have to click on the new script file. So now you can start the programming. So first I can give the heading. So every comment we define by using a percentage in a MATLAB software. So first I have given the percentage. Now you can write FIR filter design using window function. So herewith, so first again we can design a window function for low pass filter, high pass filter, band pass filter or band reject filter. So in this program I am going to design a FIR filter for low pass filter using window function. So this is my comment. So FIR low pass filter designing FIR filter designing using window function. So this is my first program. So I am going to design low pass filter using a window function. So we know that for any designing purpose or any design of digital filter, basically we are designing a digital filter. FIR filter designing is nothing but we are designing a digital filter by using a window function. So already we know that for any designing purpose we need some cutoff frequency, then and then only you can design a filter. So for low pass filter now I can design, or I can consider one frequency, that is a OMC is equal to, before that you can also write the two basic commands, that is nothing but clear all, that is nothing but clear the workspace, and the CLC for to clear the command window. And again you can write close all for to close the previous figure window. Now you can start the program. So I can define a cutoff frequency, that is nothing but omega c is equal to 0.5 into, now I will define pi. So here is the cutoff frequency 0.5 into pi. Then now I can take number of samples, so I can take overall n is equal to 25. So actually I am designing this low pass filter for the 25 samples, so you can take n is equal to 25. Now already we know that in each and every formulas of window function we need one variable, that is nothing but alpha. So the alpha is equal to, is always n minus 1 divided by 2. Then you can write, so here I am declaring some variables, so that variables are required in equation. So here epsilon value is 0.001. Next, now I can define a axis interval, so small n is equal to 0 as to 1 as to capital N minus 1. So this signal will start from 0 and it will end at 24 samples. Basically there are total 25 samples, so our signal will start from 0 to 24 with the interval of 1. Next, now we know that theoretically we design a window function by using a desired impulse response. So basically in equation or in a question we have to know about the desired frequency response. If you know about the desired frequency response, then and then only you can design a FIR filter. So for that I have to define the desired frequency response, that is nothing but HD is equal to, so now I can define one equation, that is nothing but desired impulse response, sine, again in bracket, now I can define omega c, then it's into, again in bracket, small n minus alpha plus EPS, now I can complete the bracket, divided by, again in bracket, pi into, again in bracket, n minus alpha plus EPS, bracket complete. So we know that as per the matrix multiplication or division, we need the dot variable before the division. So here I have taken the dot. So next, so this is nothing but desired impulse response. So we have a n is equal to 25, cutoff frequency 0.5 into pi, we have a alpha value, we have defined some variables, we have defined the x label axis, then we have defined the desired impulse response, that is nothing but HD. Now we can design a FIR filter for low pass filter using a window function. Now first I can use a window, that is nothing but for rectangular, so here it's spelling mistake is rectangular window. So this is the first. Now I can declare, that is a WR. So basically WR is nothing but notation for rectangular window. So in a MATLAB software we have a one directly command for the rectangular window. The name of that command is nothing but boxcar. So I can write boxcar of number of samples, that is nothing but capital N. So this command will directly find out the window equation for that particular samples. So the boxcar is nothing but rectangular window function command. So in same way, now we have a desired impulse response window function. Now you can find out the only impulse response, so that is nothing but Hn is equal to WR So here we have to take the dash. So the reason behind this is very simple, that WR, that particular values in the row form. So for the multiplication purpose we have to convert that WR into the column, so that's why I have taken WR dash. So WR dash into, so again before the multiplication you have to take dot into HD. So here you will get rectangular function into the desired impulse response, that is nothing but your actual impulse response. So after that I have to define some axis, so that is omega is equal to 0 as to 0.01 as to pi. So this is the frequency axis. Now I can find out, so already we know that our aim is to find out the FIR filter design. So basically FIR filter design is nothing but digital filter. So the output of digital filter is nothing but transfer function, and that transfer function is always in the form of h of z. So for that we have to take one command, that is nothing but frequency z. So this frequency z is nothing but it convert that equation in the form of frequency, sorry, in the form of transfer function. So frequency z in bracket, so we have to take impulse response, then one is a constant term for that particular frequency z command, that then is omega and bracket complete. Next, now I am going to plot this relation, that is omega divided by, so first I will take omega divided by pi as a x comma. Now I can find as a absolute value of h. So absolute value of h is nothing but we are finding that the magnitude of that particular filter, so is nothing but absolute of h. Then now the next aim is nothing but I want to plot all the window function on a single figure window. So that's why I have to hold this particular figure, so that's why I'm using hold on command. So the meaning of hold on command is very simple. This command will hold this plot or this figure up to when we are going to hold of that signal. So we can plot number of signal on only one figure window by using this hold on command. So this is the first. Then now you can write percentage for Hamming window. So again I can write WH is a output argument for the Hamming window, equal to the command for Hamming window is nothing but Hamming in bracket, the samples are nothing but capital N, is equal to again impulse response is equal to WH dash dot into HD. Already we have taken omega, so there is no need to take omega, so you can write, so just I can copy this, so just I have to change H1. So already we have taken the H, so I can take H1, then here I will take HN1. Next again plot command again is the same. So here I can change, that is absolute of H1. Now the color for this particular signal is nothing but black, so the black is default color, so there is no need to define here. So if you want to give some color, because we are going to plotting that all signal on a single figure, so if the color of all the signals are black, in that case is not possible to understand where the rectangular window signal, where is the Hamming window signal, and where is the Blackman window or hanging window. So in that case, for the identification purpose, you can define a different color for a different window. So here I can use one command, that is nothing but color. So I can use here the red color for the hanging window. Okay, next, now again I can copy this particular program, copy paste. So now my third program for hanging window, so here I can change as a WN, here I can change hanging, here I can change HN1 as a HN2, here I can change HN WN dash, here I can change H2, here I can change HN2, here I can change absolute of H2. Now here I have to change the color, so now I can use blue color. Okay, so this is the third window, hanging window. Again I can copy this program, copy paste. Now I can design a FIR filter by using the fourth window, that is nothing but Blackman window. Again I can change, you can write WB as a syntax for the Blackman. So here again I have to change the command Blackman. Then here I have to change HN3, here I have to change WB dash, here I have to change H3, here HN3, here I have to change H3, again I have to change the color. Now I can define green. Okay, so all these are nothing but window function. Now the next one is if you need vertical and horizontal line on a figure, so you can write grid on command. So through this command on the figure window you will get horizontal and vertical line like a graph paper. Then you can define X label. Basically X label is nothing but normalized frequency. Y label is nothing but amplitude. The last one is nothing but title. FIR designing using window function. Okay, now all these four signal will plot on the single figure window. Now already we have taken the hold on command, so I have hold a rectangular window, hanging window. So there is no need to write every time hold on. So for the single plot you can write a hold on. So after that all the plot will be hold till when we are not going to hold off the signal. So you can use hold off. So finally that all figure window will be hold off. So all these four signal will be plot on the single figure window. So once again I can explain. So we are designing a FIR filter design using a window function. So basically we are designing a low pass filter, FIR low pass filter using window function. So here I have taken the some cutoff frequency 0.5 into 5. Here is number of samples. So obviously in a window function we need a alpha, so that's why I have defined the n-1 divided by 2 is a constant term already present in theoretical concept. This is the one of the value which is required in equation in a desired impulse response. HD is nothing but desired impulse response. So here I have taken one equation for the desired impulse response. So then this is a rectangular window function. So for that we need one command, that is nothing but boxcar. So first we have taken the impulse response by multiplication between window and desired impulse response, that is nothing but HD. So we have taken the frequency Z, so through that we can convert or we can find out the digital filter, that is nothing but frequency Z. So hold on for hold purpose, then just we have replace the command, that is the Hamming window, the command is Hamming. For Hanning window the command is Hanning. For Blackman window we have a Blackman command. So now you can run this program, just click on the run. Now you can save this program in your folder. There is a problem in again. So here I have given the name FI13. So you can give the any name. Now you can check. One minute. So once again I will open the program. Okay, so I can run this. Okay, so there is some problem in program. So vectors must be the same length, so the line number 17 have some problems. So what is the problem? Maybe this has the problem. Once again you can run the program. So I can clear the command window. So this is nothing but trial and error. So you have to check the some program before. Again there is some problem. Vectors must be same length. So what is the problem? So I have to check some errors. So is a plot absolute of H. So here something problem is there. Yes, here is a problem. So we have taken the W is equal to 0 as to 0.01. So this is the actual correct. Again yes, so is a case sensitive because we have taken the capital T. So now here you can see the our output. So there are total 4 signals. Now you can check the output. So there are 4 signals. Now if you observe the output, it's clearly define the output. Just a minute. So there are 4 signals. This is a low pass filter designing. So one is a blue, one is a green, one is a black, and one is a red. Now you can see that for some signals have some ripples are present in a passband and stop band. So basically this blue color define some maximum ripples, and we are using this blue color for the hanging window as per the programming. So here you can see the blue color for the hanging window. So basically this blue color defines some ripples in a passband and stop band. So like this you can design any filter by using a window function. So for example, same way you can design a band pass filter also. So for band pass filter there is no need to change any programming, just you have to change only one thing. So I can do one thing, I can copy this program, just I can paste. So just I can change FIR band pass filter. Okay, so all the things are same, but we know that for band pass filter have a two cutoff frequencies. So we have to define two cutoff frequency, that is omega c1 is equal to 0.3 into pi, and omega c2 is equal to 0.8 into pi. So we have defined two cutoff frequency for band pass filter. Now again you have to change this equation. So here omega c2 into n minus alpha plus epsilon, then minus in bracket sine again bracket omega c1, because we have to take both frequency, again in bracket n minus alpha plus EPS, and then you can complete the bracket. Okay, so here with now I think it's extra bracket is here, so you can change the bracket. Okay, that's it. So all other program become same, there is no need to change anything. So directly you can run the program. Again you can save this program. Again you can give the name. Yes, now you can check this output. So this is nothing but band pass filter. So band pass filter is nothing but first it reject the frequency, then it pass the frequency, then it reject the frequency. Now you can check their response. So this is for blue, means for hamming. This is green color for the Blackman window, this blue color for the hanging window, the red color for the hamming window, and this black color is for the rectangular window. Now this is all about the FIR filter designing using a window function for low pass filter designing, band pass filter designing. Now this is the actual output. So if you want to take this output of this particular window, then just click on file, sorry, in edit option. So in edit option have one option is there, that is nothing but figure properties. Just click on the figure properties. Basically the background of this window is nothing but black. So if you want to change, then just you have to check the color. So here is a figure color, just click on the white. So the background of that figure will be, you will get white. So now you can take the printout. So directly click on the file option, and here you can take the printout. So in that case you will get the proper printout. So don't take the take print screen option. So if you take directly print screen of that window, so in that case you will get a black background. So for that this is the procedure. So through this procedure you can take the good printout for your experiment purpose. So I hope you like this video. If you have any doubt about the how to design a FIR filter using a window function, then you can comment on my video. If you like this video, then please subscribe my channel, share and like my channel. So thank you all of you.